Hello everyone. So here I'm going to show a quick demo about my cloth physics simulation. Okay, let's get started. Let's play the scene. Okay, cool. So okay, first increase stiffness a little bit. Okay, so I am using mass spring system to for my cloth. So you can see these are the cloth grid settings. So you can play with these values. Then these are the cloth properties. So okay, let's show me the how the grid looks like. So this is the grid, right? So these are the properties, like you can play with mass, stiffness, like the spring stiffness, the damping value, wind strength, and the drag strength. I'm just going to show you quickly. So if I increase the mass, you will see, you see like cloth is sagging. So that's normal. We expected such physical behavior. Similarly, if you increase the stiffness, so it will be rigid, like it will be like kind of stronger, I should say, like it will not sag. So yeah, and you see things are sagging. Yeah, so with stiffness the connection feels more tight, more rigid. So similarly, damping and wind strength, like if I apply wind flow, you will see cloth is moving. uh, then I can increase the damping value so that the movement will be the movement will slow down with the damping force. And again, drag strength, I can drag it, you can see. And here I'm using semi-implicit Euler. There are two other techniques I implemented, Varley integration and PVD. I will come next. So the important thing here is, when first of all this semi-implicit Euler, these are conditionally stable, like we need to play with these values very carefully, otherwise it will explode. And one, like while I was playing with my system, what I realized, like if we use square grid 32 by 32, let's say, it will explode. It's very hard to make it stable. But if you like if you use such kind of rectangular setup, so it's at least I can play little bit before exploding. So let's try to play with this, increase the drag and try to pull a few vertices. So in Euler you see, like when I pull, it's quickly uh, it quickly gets a snap back to its rest position. Like the cloth does not feel that lively, I should say, but at least you can play with this value. You can reduce the stretching a little bit, maybe. Yeah, yeah, like it feels like over damp. I think this is normal behavior from Euler. So yeah, you play with these values and get the feelings. Let's go to the next one. Varley integration. Let's play the scene again. Okay, so, wow, let's increase stiffness. Okay, cool. So as usual, you can play with mass. Same thing applies here. Like don't play with square, like a square setup, the grid setup basically. And also remember, like when, because I think I can, the minimum mass value is 0.1, but when you are going in decimal range, be careful, don't go too much low, then it will start exploding, because the velocity and force increase immediately. So that's why I'm not going to the like the mathematical numerical details, because those things are implemented in code. You can check those things. I'm just mentioning things you should be aware of. So similarly, we can add some damping. sorry, add some wind strain, and you will see the cloth is way more lively than semi-implicit oiler. And when I drag, you see it's you see that little bit oscillation, like at least it gives you the feelings of a real fabric. But again, I need to be very careful, like if I put too much force, drag force, so it might explode. But just to show you, let's make the stiffness little bit less. Yeah. Okay, cool. And then what I want to show here, yeah, increase the wind strain and minimize the damping. So you see the motion is way more better than semi-implicit oiler. The way cloth is moving. So at least it does not feel like over damp, which is kind of feelings we had in case of semi-implicit oiler. So Winston, damping, drag. Anyway, you play with these values and have little bit fun with this simulation. Okay, let's go to the next one. For PVD, it's very stable, like it's numerically robust, so I can increase the height little bit. Let's play. Okay, so damping to make it stable. Okay, cool. So in PVD, again, similarly everything applies, but it's numerically stable. Numerically like numerically really stable. So you can increase values and drag, reduce the stiffness. But in this case, like if I increase the mass, it does not have any impact because I am using classical PVD. We need to implement XPVD to get the mass effect here. But anyway, that is the limitation for classical version. So yeah, so stiffness, and you see the cloth is less lively compared to Harley, but it's very numerically stable. Like you can increase these values, it will not explode. But when I drag, is you see like it's not going that far while I'm dragging. Let's put maximum force. Hey. Yeah, it's feel very tight. Even if I am okay, let's reduce the damping so that it will maybe little bit better. Yes, but it is very stable, so just feel free to play with those value damping. Reduce damping, maximum wind. Yay, cool. Okay, so that's good. Let's go to the collision part because the PVD is very numerically stable, so I use that uh, for collision to I'm going to show it to you now. Let's make this thing wind strain 0, make it stable quickly, increase the stiffness. Okay, let's get set up. Okay, it's stable now. Now what we'll do, I will show you the collision with sphere first. Let's bring over the sphere and let it fall. Okay, damping is too high. Yay! So you see it's nicely wrapped. And you can see the gizmo view. Maybe I can drag. Yay! And then over the time, we like if we wait a little bit, we will see. Okay, let's reduce the damping so that we'll see the tangential motion, like cloth is coming out of sphere. Yeah, you see. Okay, so this is good. Let's bring it on top of cube, let's say. Yeah, the stiffness is quite high, that's why it's like jumping. Bring it again cube. Yes, let's turn off the gizmos. Whoa. Add some damping so that maybe this time it will say fast. Okay, let's slow down. Yeah, so that's about cube. Those are primitive shapes. Now let's try with this elephant, the 3D mesh. Let's bring on top of 3D mesh. Yeah, and I can, so I'm using this bounding volume hierarchy tree for collision detection. So you can see the tree here I use for this 3D mesh, and this is the bounding box. Okay, okay, these are not that important, but yeah, so play with it and have fun. That's all I want to show it here. Thank you guys. Bye. Come on.